Greetings, and welcome to Eureka Math Squared. This is grade 6, module 4, lesson 18. We're hanging out with inequalities today. Inequalities. All right. And it has the word equal hanging out in there, but an inequality means not equal to. So it's kind of how I teach it here. An equation are two things that are separated by an equal sign. So let's say we have a 2 plus a 3 equals a 5, right? So whatever is on one side of the equal sign has to be equal on the other. Well, an inequality doesn't work like that. An inequality could be something like, let's see, 4 is greater than 1 plus 2 kind of thing. So this is an inequality. They are not equal to one another. And so we're working with symbols like greater than, or less than, or greater than and equal to, or less than or equal to, that kind of thing. So that's what's going on with this particular lesson. And well, I guess they want us to start off with some graphing. So we'll hang out on page 227. And let's begin here. So we have some value here, which is going to be a greater than a -2. Now, if this was p equals -2, right, we would just find that -2 and put a big old dot right over there, and put the variable right there, and we'd be good to go. But this is an inequality, and an inequality means, well, for this particular inequality anyway, this is saying that p is greater than 2. P is greater than 2, right? P is greater than 2. Now, if it's greater than 2, then excuse me, -2, then it can't be, let me put that negative in there, then it can't actually be -2. Now, what's interesting about that is before we put a solid dot right there to show that something was -2, but now we need to show that something isn't -2. -2 is not included. So what we do is put an empty circle like that, okay? And since p, the value, can actually be greater than -2, that means -1 counts, 0 counts, 1, 2, 3, all of these values, anything, a -1.5, a -0.5, any value to the right of that -2 on the number line will qualify, right? So what we do here is just draw an arrow, and then we put in, excuse me, yeah, we just draw an arrow, also known as a ray, to the right of that -2. Once again, notice that -2 is not a solid circle. It's an empty circle because we are not including a -2 with that. Okay, so p could actually equal a +2, p could actually equal a -1, p could actually equal a 5. It could do all of those things, and that's why we're doing it like that. Okay, so p can actually be any value that is greater than -2, and the arrow, right there, this little guy here, symbolizes that. Okay, so that's how that works, and maybe we'll do a couple more in a minute here, but let's see what else is going on. Perhaps this should have actually happened first, so we have a good understanding of inequalities. So here I have a y plus a 5 is greater than -14. So this side, right, of the inequality must be greater than this side. Now this side is 14, so this guy here, whatever happens, has to be greater than 14. It can't equal 14, it must be greater than. Okay, so they give us some choices to deal with here to plug in. Don't forget that 36 over there, right? So let's see what's up. It says y plus 5 gives me something greater than 14, but if I substitute a 0, let me get rid of all this other stuff so you can see a little bit better, right? So if I substitute a 0, that would be 0 plus 5 is greater than 14, right? 0 plus 5 equals 5. And now, is this true? Is 5 greater than 14? The answer is no. So 0 doesn't work, okay? So then you try the next one. Next value is a 4. Well, if you add those, you get a 9. 9, again, not greater than 14. So that's out. Okay? And you keep on going until you find the ones that actually work. Here's a 7, right? That gives you 12, right? So 12 is also not greater than 14. So 7 is out. And the next value, right, is a 9. Well, 9 plus 5 is 14. Well, guess what? Is 14 greater than 14? No, the answer is no, it's not greater than. It's equal to it, but it's not greater than. So that one's out also. The other guys will actually work. So, and that's pretty obvious, right? So if we were building up until that 9, that actually equaled 14, then everything else that's greater than that 9 is going to work, right? Because these guys together gives you 18, and that works, which means the 24 is going to work, the 18 is going to work, and so is the 36. So what I do is I make a fun little bracket there, and I'll put the 13, the 24, the 28, and the 36, and those guys all work, okay? And it's fun making those brackets. So next one here. Okay, so this is using multiplication. All right, so we have a 3.5. I'm just going to make a little more room here. Is less than, so this side of the inequality has to be less than a 7.6. All right, using multiplication. So let's see here. Let me do some work over here. So the 0, right, let's get rid of all this, start fresh. So the 0, well, if I put a 0 in here in place of that W, right, I have a 7.6. Well, this is 0. Is 0 less than a 7.6? The answer is yes. So let me start my fun little bracket. 0 works, okay? Next one. What about a 3.5 times the 4, right? Well, 3.5 times 4, let's see, that's a 20. That's a 14 decimal there, right? So let's see, is 14 less than 7.6? Well, no. Okay, it's greater than it, so that doesn't count. And all the other guys, clearly, if I'm multiplying by a 3.5, are going to be greater than that 7.6. So guess what? 0 is the only number that actually qualifies for an answer there. Okay, and that's it. All right. So, well, I guess we could do a couple more. Let's have some fun. So let's cruise on down a little bit. And let's see if we can get into that little practice area. There it is, practice area. And that's on page 231. Put that in there. So that's page 231. I love graphing these things. They're a lot of fun. So some value x is greater than 2. Now remember, I'm not going to fill in that 2 there because that would mean that 2 is included as if x equals 2. So I'm not doing that. I don't want to. 2 doesn't qualify. So it's an empty circle, but it's greater than 2. So everything to the right of 2 will qualify. And so you put an arrow to the right. This guy here, P, is less than 7, not less than or equal to 7. If it was less than or equal to 7, right, I'd fill in that circle, but it's not. It's just less than 7. So I put an empty circle, and since less than 7, that means 6 would work, 5 would work, 4.5, all these values to the left of 7. So we make an arrow to the left of that empty circle in that 7, and that is P is less than 7, and this guy is x is greater than 2, kind of like that. Okay, let's see. So what are 3 solutions to the inequality in problem 2? Oh, what could be a solution? Well, it could be a 6, it could be a 3, anything to the left, anything to the left. It could be a -2. They all work. In fact, there are an infinite amount because, well, these values just go on and on forever. And that's the next question. How many solutions to this particular inequality actually exist? And, well, there are an infinite amount. There are an infinite, oh, I spelled that wrong. Finite amount because there are an unlimited, keep spelling everything incorrectly, unlimited amount of values, see, on a number line. Yeah, true. Okay. Let's see, write 2 inequalities that each represent the solutions graphed on the number line. Use x as a variable. Oh, all right, let's see. Let's see, write 2 inequalities that each represent, all right, so we got this guy over here, right, what this represents. Well, let's see, we're using x as a variable, so I have an x, and clearly x is going to be less than, right, because everything's to the left, less than that -1, but not equal to. Notice the circle is empty, right? But another way to write it is to start with a -1 and say, hey, -1, right, is greater than is greater than x, like that. Basically, what I do though is I start reading from the exponent. So if the exponent is here, I'll read that way. But if the exponent's over here, I'll read this way. Basically, and you'll say the same thing. So that's kind of like my little trick. I always start reading from the exponent. Okay. And that's basically it, folks. All right. So hope you enjoyed that. That's the deal with inequalities, at least for this particular lesson. All right. So math rules. Have a great one. Take care. So long. Bye bye.